Okay, there's one last method to factor in quadratics, or that we can use for factoring quadratics, but it only pertains to a very, very specific kind of quadratic, right? And that would be what's called a difference of squares. Okay, so I'm going to add that in here. Difference of squares, right? And this involves quadratics that basically look like this. Some number squared minus another number squared. This is always factorable. We can always factor this into a binomial, a pair of binomial conjugates, right? So this would always factor into a plus b times a minus b, right? So some number squared minus another number squared is always equal to that number plus the other numbers multiplied by that same number minus the other number, right? So let's look at some examples, right? So right here, we've got three clear-cut examples, and here we see the identity again, right? And that's basically what it is. It's difference of squares identity. This, right, and this, they're identical. They're equivalent. So right here, what I basically have is a number squared minus another number squared, which means I can factor this into this times this. The problem is it's not so obvious what this number is, right, if it's already squared. Okay, so this is obvious. The number squared, x squared, minus this, not so much. Well, duh. What number times itself gives you 144? Or think also, what is the square root of 144? We can say 12 squared. Right, so now it resembles this form here. And that's very simply just going to plug into this guy right here as x plus 12 times x minus 12. Right, and just to prove a point, if I FOIL this back out, x times x is x squared, x times negative 12 is negative 12x, 12 times x is positive 12x, and positive 12, negative 12 multiply to give you negative 144. We combine like terms, well, that just gives you 0x, which is just 0. So now we just have x squared minus 144, and we're back to what we started with. Right, so again, this is a useful identity. So anytime you see a difference of squares, it's factorable in this way, right here, every single time. Okay, let's do another one. Okay, so negative 12x squared plus 108. Right, so you're probably wondering, okay, how am I supposed to do this one? First of all, it's not even a difference. Well, do we like negative leading coefficients? And obviously the answer to that is no. So I'm going to factor out the negative, but I also need to factor out more, because if I divide 108 by 12, I'm going to get 9. Why is that important? Well, let's go ahead and factor out let's see, negative 12. And that's going to leave me with x squared minus 9. Okay, and why that's important is if I distribute this back in, it would go right back to being what it was, right? But now this in here matches this right here. Okay, this x squared is a perfect square, and so too is 9. So we could rewrite this as negative 12 times x squared minus 3 squared. And now we have a perfect square minus another perfect square, which is factorable into this conjugate pair here. So I can go ahead and say that this is going to become, what on tarnation? Negative 12 times a plus b times a minus b. Okay, last example. We've got another one here. This one's goofy in a different way, right? So again, doesn't quite look like a squared minus b squared. Well, it actually is. 9 is a perfect square. We saw that in the last example that we just did. X squared also we know is a perfect square. And well, no duh, so is 64, right? So I just have to think, what number times itself would give me 9x squared? Well, 3x times itself, right? 3x squared would give me 9x squared minus 8 squared. And there you have it, a squared minus b squared. And then we just plug into our identity, which is always a plus b times a minus b. So now we're just going to have 3x plus 8 multiplied by 3x minus 8. And there you have it. Okay, so that does it for factoring differences, well, factoring quadratics using differences of squares. Pretty neat trick, comes in handy a lot. You're going to see it a lot. So keep that in mind. If you have any questions over this, shoot me an email. Otherwise, you know where to find me. Goodbye.